My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 480. In this lecture, we will try to understand k-means code samples. So, k-means as far as code samples are concerned, k-means easily available in scikit-learn. It is in sklearn.cluster.k-means. So let's look at the function definition. The first parameter is n underscore clusters is basically the number of clusters you want. And for the initialization, init basically says what type of initialization you want. The default is, of course, k-means plus plus. Of course, you also had random initialization, and the next thing is n underscore int, which stands for number of initializations. So number of initializations, basically what it does is, if you see in documentation, it says that it will rerun k-means algorithm with multiple centroid initializations. This is like repeating k-means multiple times so as to get the best initializations. Even with k-means plus plus, you may want to repeat it so that outliers do not impact the algorithm much. So by default, it reruns k-means with k-means plus plus. Initialization 10 times so as to find the best solution. Then the next parameter is maximum number of iterations. The default is 300, and typically maximum number of iterations of the k-means algorithm for single run. TOL, that is tolerance. TOL here is tolerance, isn't it? Just check that parameter TOL. This is the parameter TOL. Isn't it? TOL is tolerance. Basically, from one iteration to other iteration, CI to CI to CI dash, isn't it? Max underscore ITR means maximum number of iterations. N underscore INT, that is default value, it's 10. That's what we are saying. This now we will try to understand TOL. What is TOL? TOL here is tolerance. Basically, from one iteration to other iteration, that is CI to CI dash. Let me say, one iteration to other iteration means CI to CI dash. If you are old centroid, to new centroid, how much should it change? If it is changed by less than 10 power minus 4, it would say let's terminate it. That's what tolerance here means. Verbose basically says, do you want to print more detailed data? Similarly, what algorithm to use? There are multiple algorithms. The one that we saw is the Lloyd's algorithm. There are multiple algorithms, isn't it? The one that we saw is the Lloyd's algorithm. It is very old and simple algorithm. There are many modern variations. Typically, the default is Lloyd. We choose the best algorithm based on the data sets, based on the data set is whether data set is dense data set or sparse data set. You can just leave all of other parameters to default values. The values that you probably need to change would be the number of clusters itself and probably the number of initializations that you want to try, so that you will not stuck with some outliers. Except for these two means except number of clusters and initializations, I think you do not accept these two. I think you do not have to change many of the parameters much. Let's look at the simple code snippet which is readily available readily available for us here. This is also very simple code snippet from sklearn.cluster, from sklearn.cluster import k-means. Just check it out. It is sklearn, from sklearn dot cluster import k-means. Let's assume I have some data set x. Let me say I have some data set x. I just have to say I am initializing k-means with n underscore clusters, number of clusters equal to 2, and I am saying random underscore state equal to 0 underscore int equal to R2. I just say fitx. We already discussed about fitx many times. This is exactly what you see with any classification, and any regression algorithms. What this gives you is you can also get cluster center and say what cluster it belongs to. All of that what cluster it belongs to, all of that very easily. You can understand these parameters which we discussed many times in our previous lectures. This syntax is very similar to all the classification and regression algorithms that we already seen. So it's very similar in nature, nothing fancy, except that your parameters change slightly. Now you might ask, all this is good, what about k-midoids? Unfortunately, I could not find. There are some references to k-midoids in sklearn code based, but I could not find anything in documentation. So what I did was I tried k-midoid Python, just Google search for it. Here is a very nice GitHub profile. Somebody implemented, just see, somebody implemented it. Very simple. You just have k-midod.py, isn't it? Just see, you have k-midods.py file. You can choose. If you see this particular slide, first one is what is the last one? k-midoids.py, isn't it? You can just download it. There is also an example. Somebody gives you how to use it. So if you look at this, we just downloaded k-midoids.py. So if you want to really use it, just download k-midoids.py, and all you have to do is very simple. Somebody has written this code. Please give credit to the person who has written this code. Whenever you are using someone else's code, it is always good habit to say that we have taken code. You are just importing k-midoids, and just you are saying k-midoids, we are using the data set. We are using the data set capital D, isn't it? Which data set we are using? We are using a data set known as capital D. So given your data set as data, you are computing pairwise distances, and your kernel metric is nothing but pairwise distances effectively. So you are giving that as an input, So as an input to k-midoids. It is very simple code where it says for each of your data points, what is the clustering? What is the clustering it says? What is the clustering it says? What are your midoids also? Someone also implemented the PAM algorithm for k-midoids. Somebody implemented partitioning around midoids for k-midoids. Just go through it. This code is already available. Just Google it and search in GitHub. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.